Thank you. Um, well, yeah, thank you all for being here, and thanks for the opportunity to talk tonight. Sorry for speaking in English. This would go very, very slowly if I was trying to speak in Spanish, so I apologize. But really appreciate. Oh, wait, sorry. Yeah, really appreciate being here. And yeah, tonight I'm going to talk a little bit about a couple of projects that I've worked on, all sort of in the space of machine learning and public policy. And just to start off kind of motivating things, I want to talk a little bit about some of the challenges that are, I think, a little bit unique to the public sector. One of those is very much the fact that many public agencies, many government agencies, uh, work with data systems that are very, very much out of date. So there have been reports from US government agencies kind of looking at the United States federal government saying that 80% of their IT budgets are dedicated to maintaining kind of basically archaic systems that are very antiquated, very out of date. When the COVID-19 pandemic hit, there were governors in the United States that were putting out calls not just for healthcare workers, but for people who could deal with COBOL programming because they realized that all of their systems were being put under tremendous strain, and nobody knew this language anymore that hadn't been popular since the 1970s and 80s. So this obviously creates a huge challenge, especially given the number of people that these agencies serve. But it's really exacerbated by the fact that there isn't a lot of human capital coming into government with the sort of expertise that's needed to deal with these problems and kind of bring these new technologies into these settings. The Stanford Human-Centered AI Institute has been surveying recent PhDs in AI and related fields. And really over time, they've just seen persistently folks go into industry and they go into academia, but fewer than 2% have been going into government. So there's really a lack of skill, old technologies, and you kind of pair that with a really massive problem. These agencies are serving millions of people. This is a picture from one of the file rooms from one of the agencies that we've worked with, where the file cabinets are all full, so they just start stacking stuff up on top of the file cabinets. This is all backlog. They have to get through these many files. Nothing's digitized, and it's just a tremendous challenge to kind of address. And so a lot of my work, I think a lot of work from others in the room, really hopes to answer the question of like, how can we bring to bear machine learning, AI, all these new tools that are being developed that have a lot of promise for doing things more efficiently, for getting through heavy workloads a lot faster. How can we take those and use them in the public sector? And so I want to kind of talk about a couple of stories and a couple of lessons that I've learned in my work tonight, and kind of think through some of the ways that I think these tools can be useful. I'll just sort of, oh no. Yeah, thanks. Sorry about that. So just to give a little bit of context, I'm drawing on a lot of projects with dozens of different agencies, nonprofits, that have been working with some of the different groups that I've been involved with over time. Obviously, I won't speak to every single project I've ever been involved with, but I'm kind of trying to summarize some of the thoughts and lessons I've learned across different projects into a couple of stories, and really want to also acknowledge that a lot of this is not just work that I've done either directly or kind of exclusively. This is work that has really spanned a couple of institutions, both University in Chicago and Carnegie Mellon, a group that started at Chicago and then moved, led by Raid Ghani. And then more recently, I've been at Stanford in a group led by Professor Daniel Ho. And the work that I'll talk about today has involved all of these people, as well as nearly 300 DSSG fellows. So I obviously can't acknowledge everyone by name, but just wanted to make sure that I kind of mentioned that there are a lot of people involved in these different projects. So I'm going to zoom in on 5 stories tonight and 5 kind of lessons learned. And I'll start with some work that we did with the city of Syracuse, New York, which is sort of a medium-sized city kind of in rural upstate New York. Like a lot of cities, at least in the United States, their infrastructure has really been aging and really been kind of decaying over time. And so they've been facing a lot of problems with their public infrastructure. Particularly, they came and worked with the DSSG Fellowship, trying to ask for help thinking about how to deal with water mains bursting. So this is something that is happening more and more often in cities. There's about 250,000 of these that happen across the United States every year, causing tens of billions of dollars of damage, and it's only getting worse as the infrastructure continues to sort of age and see problems. Syracuse themselves face about 200 of these a year, and don't know where in the city they're going to take place. So water main bursts, they are entirely reactive, have to go out, try to fix it, deal with the damage it caused, deal with all the disruption it caused. And so what they wanted to do with the DSSG project was really figure out how they could get ahead of things, how they could be more proactive by predicting which water mains were likely to break in the next year, and then going out and doing preventative maintenance, installing leak sensors, things like that, so they could be more efficient and avoid these problems happening in the first place. This seemed like an interesting project, but also seemed like kind of a challenging project, right? These things are buried under the ground. They are hard to access, hard to get a lot of data about. We started to talk to the city, or the group that was really working on this kind of started to talk to the city and asked, well, what data do you have? What do you know about these water mains? Can you tell me obviously where they are, but also what material are they made out of? How big is the pipe? How old is it? And they said, oh yeah, we've got all that information. It's right here in these 100-year-old engineer notebooks that are hand-drawn. So obviously this caused a little bit of a challenge for machine learning. And actually resulted in a really heroic effort of some of their interns going through and digitizing a lot of this and turning it into data that could then be fed into models, along with other information about sort of the age of the housing stock and businesses and traffic and road conditions and things like that. So pulling all that together, we were able to put together a model that was actually quite useful for them. In the top 1%, so kind of the highest risk set of blocks that they actually had resources to go out and do some sort of preventative maintenance on, about 2/3 of them, or a little under 2/3 of them, actually burst in the next year of follow-up. So that gave us a lot of hope that you could do something like this in this context, but it was really, really critical to go through and go back to those 100-year-old lab notebooks and actually bring them in and digitize them. And I think this is the first lesson here is something that I just kind of have seen over and over again. I think in academic settings, when we learn how to do machine learning, right, we're given the data set that is a single matrix with columns labeled feature 1, feature 2, feature 3, and and something labeled label, and the focus is really on kind of learning the algorithms. And in real context, right, never have I seen all the data live in one place. So this is the more extreme example, but it's always in a handful of Excel spreadsheets that live on different people's laptops, or if it is in databases, it's in 6 different databases that are backing different programs that different vendors own. And you have to really do a lot of legwork to go around and kind of gather up all the data. But that diligence really can pay off and make the difference between something that actually works, and if we had just kind of, in this case, done the easy thing and just said, oh, well, I just use census data, and what do we know about the blocks, really wouldn't have worked at all. So often the most useful information is stuff that you really have to take the time and invest the effort to go find. The next project I want to talk about is really in the environmental space and trying to uh, help think about the impact of large factory kind of animal agriculture operations. Um, these big factory farms can house like tens, hundreds of thousands of animals, and they produce really as much waste as like a large city. And the waste that is produced by these farms is not nearly as well regulated as like municipal sewage. Often farms will dispose of it just by spraying it on fields. Now, in the springtime, when that's done in kind of moderation, that makes a lot of sense. It's useful fertilizer, good nutrients. But when they're doing this in the wintertime, just on like snow-covered ground or frozen ground, the nutrients can't absorb. All that happens is it just runs off into the local waterways, and you get these really terrible toxic algae blooms and things like that. So uh, it's such a hazard in the winter that in at least a lot of states, uh, this is just entirely disallowed for them to do this. But it still happens anyway. And we wanted to try to pair the fact that satellite imagery has just gotten massively better over the last several years, as have computer vision models, to try to essentially just do object detection here and see if we could identify cases where we find this sort of like hazardous waste spreading uh, occurring in the middle of the winter when it's snowy and particularly risky. Um, and so we built, models that seemed pretty successful at doing this, just looking back at historical data and tagging things by hand. But of course, we want to see how useful is this on the ground? Could we do a field trial? And here's where we had a pretty unique opportunity to actually work with two agencies at the same time. One was a nonprofit advocacy group called the Environmental Law and Policy Center. And the second is the state regulator, the Wisconsin Department of Natural Resources. And so what we did was we said, okay, here are, in real time, the highest risk detections that we're seeing from the model, and ask people to kind of take that satellite imagery and go out on the ground and follow up and see if, if these were actual instances of illegal spreading. Uh, and both groups really kind of found very similar things, just in terms of validating the model. The highest risk events were validated at like 35, 40%, which might sound relatively low, but keep in mind the base rate here is 1% or well south of 1%. So we're sifting through many, many images that would be impossible for them to go through manually to be able to identify these events when they'd occur. So the model's working pretty well and doing what we designed it to do. But the state regulator was, because they had more access to the farms, because they could actually follow up and do a real investigation, they were able to really figure out what was going on with these events. And there they said, oh, well, when we followed up, we found that actually quite a few of these were from smaller farms, and we don't regulate those, so we don't worry about that. And some of them happened before February 1st, and the spreading, it's only illegal, after February 1st. And the model was just detecting that it was still there. And so only a relatively small number were actually, illegal events that we could go out and write people a ticket for and fine them. And so this led them to kind of come to a different conclusion from the environmental advocacy group. The advocacy group said, oh, wow, there's a lot of this going on. We care about all of this, right? All of this is hazardous. It doesn't really matter if it's from a small farm or a big farm. It doesn't matter if it was before February 1st, right? It's still on snow-covered ground. It's still going to get into the waterway. We want to be able to monitor all this, and we want to be able to advocate for change by pointing to everything that's, oh, is it a little too, yeah, quiet. We want to be able to advocate for change, and so we want to know about all this. This is really exciting. We're going to deploy it. We're going to keep using it. And the regulator said, well, we only care about the small portion that we can actually go out and find people for. So we're not as interested in this. It seems like a whole lot of work for a relatively small number of illegal events. Um, and I use this story as kind of an illustration of how important it is to really go deep in understanding the context when we think about model design, when we think about model evaluation. Here we had different organizations looking at the exact same model in the exact same point in time, the exact same location, and coming to pretty different conclusions about the utility for their operations, because one was thinking about model evaluation in terms of finding events that are against the law or against the regulation, and the other was thinking more broadly about kind of environmental hazards. And that's not just a kind of lesson from this context particularly, but any context that you work in, right? There's no such thing as overall model performance or overall accuracy. There's no single metric that really is reasonable to use across the board. And I think this is kind of another gap that, at least when I've taught machine learning classes, right? You're always kind of like, oh, people just like look at AUC or they look at F1 or whatever. And then when you go out and do a real world problem, it's like, well, I don't care about that. I care about, I have resources to look at the top 10%, and I care about how efficiently I'm using those resources. Or false positives are this costly and false negatives are that costly, and I need to balance those in some way. And so having some more nuance, thinking about how the context maps to the methods that you use and the way that you evaluate and the metrics that you use is something that I think I've learned over time. And so wanted to kind of illustrate with this project. So the third project is with the city of Baltimore in Maryland. And Baltimore is also kind of a mid-sized city. I think around the turn of the century, it was a real large industrial hub. And then over time, 50s, 60s, really went through economic downturn and really saw its population start to dwindle. And that, in turn, has led to a lot of abandoned housing. And this abandoned kind of housing stock is a particular challenge in Baltimore because most of their housing is row homes. And what that means is you have these houses that are one right next to the other that share walls. And so they all share interior walls next to each other. And so when you have one of these units get abandoned in the middle, say its roof collapses, all of a sudden the interior walls on these two units on either side are now exterior walls, but they're not made for that. So the problems just cascade from the abandoned unit to the occupied units on either side, doing a lot of damage to other people's properties. So this is actually a really significant challenge in Baltimore, and I think it's something like 70% of their housing stock is these row homes, and they've seen huge population decline over time. So they went through and tried to do a manual labeling effort, yet again, more kind of heroic. I think this was actually high school interns rather than undergrad interns that sat and looked at image after image and looked for places with damage to the roof or roofs that had collapsed. They went through something like 2,400 blocks, could only do this for one point in time, and so they came to us saying, this was great and really helpful, but we want to be able to keep up as the data refreshes. We want to be able to look at the entire city, not just kind of a subset of blocks that we pick out. So they worked with us to try to bring together both aerial imagery that they had, administrative data on previous inspections, previous maintenance, 311 calls, so calls to report issues to the government, to try to build a model to identify a list of the top 1,000 locations for them to go out and inspect, and then remediate as they found problems. So we started off with kind of what's a reasonable baseline here, and just to do something relatively simple, realized that the roof damage was generally showing up as very dark pixels in the imagery. So we said, well, how well can we do just with something quick and dirty and simple like that? Surprisingly pretty well. So of the top 1,000, just ranking by the percentage of pixels that were that dark or darker, almost half of them actually had roof damage that they would want to go out and deal with. But of course, adding ML to this is certainly helpful. If we brought in the structured data, so all the inspection history, things about housing prices, things like that, we increased this to almost 80% precision at 1,000. And then if we add a convolutional neural net on top of that, we get to well over 90%. The 80 here that's kind of in blue is actually ones that were missed by the interns doing their manual review, but found by the model. And I think this is just kind of like a nice clean story, but something that, again, I've seen over and over again, that models really benefit from using many different types of data. And that sounds almost trivial, and hopefully is, but I think the community is so siloed sometimes to like, oh, well, we're the computer vision lab, and we're the text lab, or the LLM lab, and we're the graph neural network lab, and we're the traditional ML lab, that people really kind of say, oh, I'm gonna go out and do this project, and then only focus on or only kind of try to collect the type of data that they're familiar with. And I think even something that looks like, oh, this would be just kind of a standard vision problem, as you add the administrative data, you add more nuance, and the model does a bit better. So I think it's very, very helpful to kind of think about what are all the different modalities of data that might be relevant here. This is certainly really something that I think we've seen in like a lot of the literature around computer vision and medical imagery, right? Where it's just like, oh, great, I looked at all this medical imagery, I can do pretty well predicting lung cancer, and then you put it in the hands of doctors, and the doctors do way better because, well, I know but that patient, has been a smoker all their life, or I know that this patient has worked in a coal mine, and I know that patient is has more healthy habits, and so they're informing their priors, and our models should be doing that as well. So I think the fourth story I want to talk about is work that we did with the Los Angeles City Attorney's Office. And their office is actually in charge of like prosecuting misdemeanor crimes. And something that they saw and they were really concerned with was the fact that they would see people with various unmet needs, so mental health crises, substance abuse problems, homelessness, unemployment, that those needs would lead to circumstances that would end up with them being arrested for some sort of misdemeanor, end up with them going to jail. Jail's a terrible place for those needs to get resolved. So then they get released, things are bad, or maybe even worse than they were when they first came in, and the cycle will kind of repeat itself. And so they were trying to think much more proactively rather than just saying, oh, we're a prosecutor's office and all we do is we go in front of the judge and we send people to jail. They were really thinking about, can we do things to get ahead of this and kind of break this cycle? Can we figure out folks who need connection to housing services or who need connection to substance abuse treatment? And when we see them the next time, instead of just sending them to jail again, could we divert them to one of those other sort of interventions? Hopefully that would reduce their challenges and kind of break this cycle and keep them out of jail. But they were also really cognizant of the fact that there are huge disparities and problems with fairness in how people interact with the criminal justice system. And so they want to really think about, if we're going to build models to do these sorts of things and predict people coming in and out of jail, how do we think about fairness and equity in this context? And then once we have wrapped our minds around how we think about it for this context, how does that map into what we do to the models to improve fairness? And then to the extent that we're trying to do that with our models to make them more fair, if that leads to diminished accuracy or diminished performance, how do we think about those sorts of trade-offs, and how do we kind of figure out where we are on that like Pareto frontier where we should be operating? And this project's a few years ago, and the algorithmic fairness community has really exploded, I think, since we were doing this work. I think in in our work, we were really kind of learning and starting to wrap our mind around the 30 different ways that you can even define fairness. Is it about statistical parity of the number of people that you select for intervention across different groups? Is it about that relative to their needs and to true positive rates? Is it that relative to false positive rates? Are false positives more harmful than false negatives? So we kind of start to map this out into this sort of decision tree that we use to kind of facilitate these conversations with different stakeholders, really trying to think about, in a given context, what are the metrics that make sense, or what are the ways to even turn kind of our general notions of fairness into something that we can measure statistically. This particular project, we landed on recall parity, so thinking about are different groups having an equal opportunity to receive these kind of diversions and interventions, rather than thinking about kind of other, say, false negative rate or false positive rate. So then we went and did the project as one might normally do for a machine learning project, right? Threw a bunch of different types of models at it. Looked at logistic regressions and random forests and boosting classifiers, back-tested them all with cost validation across different cuts of time, picked out the one that performed the best at finding folks who were likely to show back up in the prosecutor's office again, and looked at the ones that were doing a good job of finding the best precision among the highest risk individuals. And then we said, okay, that's kind of the standard approach. How does this model perform in terms of the fairness metric that we were thinking about? And so we looked at recall by race and ethnicity. And while we found that the model was, doing reasonably well balancing across white and black individuals, it was doing pretty poorly for Hispanic and individuals who didn't have race or ethnicity in the system, which was a decently large group as well. And that shouldn't be surprising, right? The model was optimized for some measure of accuracy, some measure of efficiency, and not, there was nothing in the objective function about fairness. So then we went back and explored a variety of different techniques and methods for, can we, put fairness metrics in the objective function? Can we do something with post-processing? Can we do something with pre-processing? In this case, we found the most effective methodology to be kind of a post-processing approach, choosing different thresholds across different groups, that let us bring the recall across groups much more into alignment. That worked quite well, but I think what we were a little bit more surprised by was the fact that there was almost no decrease in precision in the top 150, so no decrease in model accuracy for making this adjustment to fairness. And this is actually something that we've seen across a lot of different projects. I think particularly where we work in these resource-constrained settings, where there are maybe many, many more people with needs than the program can serve, and where you're trying to pick out the folks with the most risk, or the kind of a small subset of the folks who you could serve. I think there are many different ways to choose that set with many different characteristics across fairness metrics. And so what we've kind of found is that you can use different approaches. You can achieve fairness from machine learning systems, but you really have to think of it as an objective for your optimization, as a goal in itself, and it's not going to kind of come out of these systems for free, but may come out with relatively little trade-off in terms of accuracy. At the time, it was, I think, a very surprising result for us, and we looked across several different projects as we kind of continue to work in the space, and just kind of consistently we're finding that that we weren't seeing these huge fairness accuracy trade-offs, that I think, half of the papers in kind of the algorithmic fairness space start with like that sentence of like, well, because, fairness accuracy trade-offs, we're trying to do something along this Pareto frontier. So the last story I want to talk about is kind of in this same space as well, and is work with the Chicago Department of Public Health that was really focused on trying to reduce lead hazards in young children. Uh, Lead, I think, affects about 4 million kids in the United States, and it's really pretty terrible. So after kind of exposure to high levels of lead, kids will suffer learning disabilities, problems with memory and IQ, problems with motor skills and hearing. And all of these effects are really irreversible. Like once you've been exposed, you can't, by reducing the hazard, these problems don't go away. Uh, and what is really, I think, troublesome and scary about that is the fact that right now, in many communities, the way lead hazards are discovered is by monitoring blood levels in kids. And so you're kind of using the kids as lead sensors, right? Once you see, the lead in the kid, oh, then you go and remediate it, and it, stops it from getting worse, but you've already done a lot of damage, or the lead's already done a lot of damage, and uh, and so that's great for the next kid in that household, but it's not so great for for the first kid. So what CDPH really wanted to do was, again, how can we use our data? How can we be more proactive? How can we get ahead of this rather than waiting for kids to present with these problems? Um, so they worked with us to kind of try to, again, build machine learning models that used a lot of the data they had about their housing stock, where remediation had already happened, but also where kind of pulling in data from the health system, figure out where there are likely to be young children or households that already have kids that have just been born and are not yet at the age where they'll be crawling around and sticking things in their mouth, which is when this really becomes problematic. This actually, it proved to be a relatively hard problem, but even with precision in kind of the 15, 20% range, we're still seeing, 3-4-fold increases in the model's accuracy across baseline. And so that was still enough for them to say, great, let's go out and deploy this. Even if, one of every 5 houses that we go out and inspect has lead, we're still doing a lot of good. And so the general flow was, right, take this historical data, build a machine learning model, use it to predict households where there might be lead, make a phone call, schedule an inspection, go out and check for lead hazards and do remediation. The only problem here was when they started doing this, they contracted with a call center that was only English speaking. But Chicago has, many different populations, many different language needs, many different languages spoken at home. And so even though we had done work to ensure that the outputs of our model, were reasonably, balanced across different groups in the city relative to their need, that was just kind of erased by the fact that, well, now you're not scheduling inspections with folks who can't speak English. Fortunately, this was recognized and they switched to a multilingual call center very, very quickly. But I think the kind of take home here is that I think often it's easy to think about like, oh, my job is, I build the model and I need to do what I need to do to ensure fairness at the level of the model. But we really need to take systems views of these things and think about how fairness is a system property, how our models plug into and get used by downstream users, and where kind of failure could happen in those cases as well. So yeah, that's just kind of a survey. Oh, sorry, Diva.
I have a question about the net.
Yeah.
I was just curious about the historical data. What type of data was actually?
Yeah, so the historical data that the model was trained on was basically all of the like blood lead tests from the past. And so that's the labels, right? Is like, okay, where were there lead hazards? And then the features were like, when was this house built? Lead was outlawed in, do you remember, Adolfo, 70, 70 something. So, okay, if the house is newer than that, or if it's had if we have building permits, if it has had some like big renovation since then, right, it's not going to be as hazardous if it's much older. But then also thinking about really the geographic aspect of it as well, whereas a lot of these hazards are more paint than pipes. We're kind of trying to do both, but if you were thinking about like what areas were built at the same time, where were they maybe using the same paint or lead paint, and then what happens is the paint chips and pills, and then kids stick it in their mouths, and that's how lead usually enters the system, more so than water. Yeah. Cool. Well, I'll jump to, yeah, just kind of a quick recap. I kind of highlight these stories because I think they highlight some of the lessons that I've learned over time and kind of had to figure out as I've been doing this sort of work. And so just to sort of, recap those very quickly, the first was really about thinking about, all the different types of sources of data and the fact that when you go into one of these projects, it's very, very rare that all the data lives in, one nice clean place, that it's well linked, that you don't have to spend a bunch of time, figuring out how to connect it across sources. How important context is to everything about the machine learning pipeline, and how much time it takes to just really dig into, what is the data generating process? What is the problem I'm actually trying to solve? What do folks actually care about? If I just give them, a model with high AUC and they're only operating at one point of the score distribution, that just may not be that useful for them. So how do I make sure that the optimization I'm doing actually relates to the problem that I'm trying to solve, and it's going to be useful on the ground? All the way down to doing things like ride-alongs and going out with people on inspections and things like that. It's just really valuable to get that level of understanding of the context that you're working in. The fact that models really benefit from kind of pulling together a wide range of different types of data and different data sources. The fact that fairness is, I think, a pretty achievable goal, often without too much trade-off in accuracy, but really has to be something that you go out and seek, and really you think about not just as a function of model outputs, but as a function of the system that is using the model. So yeah, those are kind of my thoughts. Hopefully it's useful, and I'll just put up my information here. I have the link there both for Stanford Reg Lab, which is the group I'm currently with. I know, they're always hiring, and then also Raid's group now at CMU, and I think, both good places to look for other projects and, other things to kind of get involved with. So thank you again so much for the time. Happy to take any questions. Don't want to stand in the way of drinks and stuff too.
Bien, creo que podemos hacer un par de preguntas. Si tienen algunas preguntas, yo creo que puedo empezar. Si me quieren hacer en español, puedo ayudar, o si me quieren hacer directo en inglés, yo puedo empezar con la primera. Because I was curious, I saw that in the project you were working with Infonavit, which is a Mexican.
Yeah, and that's what. Adolfo, did you do more of that? Yeah, you did a lot of that, so he can answer all the.
Oh, perfecto. Sí, I was just curious about it because I think what it's a lesson here, especially, is that there's a lot of data, there's a lot of projects, and there's a lot of opportunities. Doesn't matter where you can place them.
Yeah.
But I think that my question here is how you can actually pinpoint that, like how you get an interesting problem to start working, because it's not that we want to apply data science, it's that we want to solve a problem.
No, I think that's actually a really great question of like, even upstream of all this, right? How you choose the projects and how you're also optimizing your time and where you're going to spend it. And I think that's something that especially kind of on the DSSG side, we spend just a tremendous amount of time scoping. So I think for the summer program, at least in a typical year, right, we'll kind of put out, oh, here's a call for proposals, basically, for people to say, oh, I'd like to do a project with you. And we'll get, maybe 50, 75 of those. And then kind of divide and conquer. A lot of people get involved and have, introductory calls, learn about the project, learn about the problem, and really kind of think about it in a pretty structured way of like, okay, what's the goal? What what's the intervention? Like, can you, if I build a model for you, can you actually do something with it? And I think a lot of projects kind of fall off at that stage, right? Oh, well, we just want a dashboard, or oh, we just want a map, and you're like, well, but how's that going to change your decision making? How are you going to actually take that and use it to change your operations and intervene in ways that'll be useful? So I think that is like one of our kind of key points is the utility. Especially for this work, right, we're really looking for social impact. So we're also kind of trying to balance, does it look like, okay, you've got a great intervention, but it's really narrow in scope, or it's really only going to help people, a little tiny bit versus something else that might help a lot, right? Oh, we're able to help people, get them off the street for going from homelessness into some sort of supportive housing, might have a bigger, kind of impact on them than something that is a very small scale intervention of, say, like we're sending people $20 gift cards or something like that. So, kind of thinking about the scale of the intervention, the scale of the impact, and then is there data available? How, I mean, the 100-year-old notebooks aside, right? Like how readily available is the data? And how much do we think, even before building any models, the data can actually be used to predict this outcome, or to make this optimization? So I think those are kind of the big dimensions that we really think about of like, is it feasible? Is it impactful? And kind of as a subset of, is it impactful? Are they actually going to do something with the model or the system that we build? Is that helpful? Yeah. Yeah. Is there?
Yes, sir.
Yes, I have a question. It's related with I saw that you presented collaborations like with 5 different government institutions.
Yeah.
But what I would like to know is what's the process? Because I guess that we in Mexico need to with the institutions or companies or the university of the
Yeah.
or how it happens, because I think that here we don't know how to make that.
Yeah. It's not an easy question, unfortunately. I mean, because it is a lot of work to really kind of establish these relationships, and it requires a lot of flexibility. I mean, there've been cases where I'm onboarded as an intern with one of these agencies, so I can like use their systems, and all the work happens on their servers. There's others where we're able to get a data use agreement, and they send us data, and it kind of depends on the sensitivity of the data and their kind of risk tolerance, and how they think about. But most agencies, I would say, that we've worked with, Adolfo, you can probably chime in as well, right? I mean, I would say a lot of them really don't have prior experience doing these sorts of partnerships. At best, maybe they've worked with the university in kind of the more traditional, like, oh, they threw some data over the wall and they anonymized it or something. They threw it over, and then people went off and wrote some papers and never got back to them, right? And this is really much more about partnership and about kind of trying to work with them very, very deeply, and getting to know the problems that they're actually trying to solve, and then deliver something that's useful for them. So I think that goes a long way in building that trust of making sure that you're really there to like learn about the problem. But then the mechanics of like actually executing a data use agreement or actually getting onboarded through, I mean, it's in the United States, it's a mess because there's like different mechanisms at the federal level and at state level and at local level. So I definitely, yeah, very much like feel the pain that you're. But I mean, but it is possible, right? And we've done it over and over again. And a lot of it is finding kind of the right people in the organization. And once you have kind of a champion inside who can really kind of push things forward, that helps a ton. Yeah. Oh, sorry.
Okay. Nice to meet you first.
Thank you.
And second, speaking of the Syracuse case, do you think there is a correlation between not wanting to optimize projects like this one, and for consequence, reducing the amount of budget needed, and the corruption well known with the manipulation of the data, speaking of the budget, or individual benefits in public agencies or public, how are you going to say, areas?
Yeah, no, I mean, it's for sure a fair question, right? And I think varies a lot. I think back to the point of like, how do we select, agencies and governments to work with? I do think, right, we are also looking for agencies, organizations where we feel like they really are kind of motivated by doing something useful and impactful. And I think the vast majority of the cases, at least that I've experienced, are agencies less where kind of, those sorts of risks of like gaming or corruption or things like that are very salient, and much more where you have a very small team with just an enormous problem in front of them, and they're just stretched too thin. And so there's not like that much likelihood of like, oh, if we focus on the right, water mains, right, we'll get less budget for our parks, for our transportation department or something like that, because it's such a big problem, and they can only kind of like, well, let's just try to optimize away the worst of it. But I don't think, I think they're kind of like understaffed and under-budgeted relative to the scale of the issue as it is, that being more efficient won't necessarily create motivation to reduce their budgets, at least in a lot of the cases I've encountered, if that makes sense. Yeah.
And I have a second question.
Sure.
That there is it's a more personal one. But have you been in cases of dealing with deception, like manipulating information in your area of working, like to, I don't know, enlarge or
Cherry picking?
what?
Cherry pick, yeah, kind of.
Yeah.
Where people are asking
Something
like,
that.
oh, hey, we really need this model to show this thing or something
Yeah,
like that.
so as a data scientist or data analyst or this kind of area of work,
Yeah.
I think it's a big problem if you have like your bosses or something. Speaking of public agencies,
Yeah.
to decept the information,
Yeah.
So have you been in those cases, and if so, how well it went?
Yeah.
The street.
Yeah. Right. No, I mean, I actually feel fortunate that I haven't really been in those cases. Part of that probably is a function of how much effort we put in up front selecting the projects that we're willing to work on, because I do think we do so much diligence on, especially asking the questions about like, well, what are you going to do with this model? How are you going to use it? How is it actually going to translate into something on the ground? It's funny though, because I think I've always personally sort of thought of that more as a problem in the private sector than a problem in the public sector for kind of cherry picking or things like that, where where people are kind of like, oh, they've got this like financial incentive that they want to show, look at how much impact our work is having or things like that. But I can see how, right, if you're thinking more about models for, or less models probably, and more kind of data science in the sense of like measurement and maybe impact evaluation or things like that, where people are saying like, oh, I need to report up to my boss and show that this program I am investing in is really working. Like I could see the incentives being there for in the public sector. It's something that I haven't had to deal with personally, which I'm glad for. But definitely something that, yeah, is like a real challenge and real risk. Yeah. Or-
Could you tell us more about this Stanford Lab in the direction that if you are open for new partnerships, new projects, maybe some other universities that want to collaborate in the projects? I
Yeah.
heard that you have like lack of hands in this kind of areas. So for me, it's interesting to know.
Yeah.
For example, I am studying my master, and if there's a chance that collaborating some of these projects would be great to know that, right?
Yeah, definitely happy to speak a little bit more about RegLab generally, and really also, you know, Raid's group at CMU is very much in the same, you know, the same kind of vein and same space. RegLab particularly does a lot of work focusing on kind of trying to partner. I mean, a lot of these projects are, I'd say the environment one about the factory farms is work from RegLab. The others here are either from the summer fellowship or from U Chicago and CMU. But they're, you know, they very much kind of speak to each other in the sense of trying to find governments to partner with. RegLab has done historically a lot of work on environment, tax policy, thinking a bit about AI regulation lately with all that's been going on, as well as a little bit around health and equity and things like that. I don't know, you know, what details are particularly helpful. I mean, it's a kind of groups about 40 or so folks, I think, total, and really draws on a lot of people coming, yeah, out of master's programs, even out of bachelor programs, a handful of postdocs, a handful of PhD students, and tries to find projects very much, you know, along those same dimensions of what's impactful, what's useful. So I think we're always open to kind of have conversations about exciting things that are in that space, for sure. And then, yeah, very much, you know, always looking for folks who are excited to work in that area too.
Programas unidos. Ahorita te cuento, ¿no?
Okay, so thanks for your presentation.
Thank you.
Well, you know, useful. My question is about, I didn't get it well with the projection, with the project about the project, you know. How did you get that conclusion about the optimization that about that model was the right answer, the right, you know, and about this problem. I didn't get it well, no? So
Sure.
I would like to know more about that.
Sorry, I missed which project?
What?
Oh, which?
Yes, Turney's Institute project.
The
CD of
Oh, the Los Angeles. Oh, the attorney project. Oh, sorry. Sorry. Misunderstood. Well, and it's a good question, right? Because I think I don't know if I have. Yeah, I guess I don't have something that's too illustrative here, right? But what's interesting here is we are making, you know, a relatively strong assumption that the top 150. So what the model is predicting is who are the 150 people that the city attorney's office is most likely to see again in the next month or so. And the reason why the 150 comes from basically they have enough resources to look through all their old case files. And it's really kind of a mess because people get arrested. Sometimes they're linked to like previous times that they've interacted with the city attorney's office. Sometimes they're not. But often what happens is the city attorney has like an hour to look at the case file and then go in front of the judge and decide what to do. And so they said, this is a disaster, right? We can't think about their history. We can't think about what's going on with this person. We just go into court. They end up back in jail. It's terrible. So what they wanted to do was let's find people who we're likely to see again very soon and spend the time ahead of time figuring out what's going on with those people, figuring out what connections they might need, what social services might help break the cycle, and kind of have a tailored intervention waiting for them. So then if we do see them again, if they do get arrested again, we can do something better than sending them to jail. And so the big assumption that we're making there, though, is that, okay, right, we can add some efficiency and help you, figure out which cases to focus on to get ahead of people that might come back. But those might not necessarily be the people who will be most helped by one of these interventions. And in this project, what we're kind of doing is really sort of, relying on the expertise of the people in the city attorney's office to kind of add that component in, to look at the case and make a decision about what they should do about it. But I think that would have been, unfortunately, this project kind of didn't get to go too much forward from this level of kind of validation because they had a lot of like turnover in their staff, and so we weren't able to really get to a point where we could then look at people who had these tailored interventions, help them, and see how much, right, then you start to get feedback and labels back to understand, oh, who's helped? Can we predict what services you actually need? Can we make that next step even more efficient and maybe even, take that 150 and turn it into 300 or expand the number of people that we can help. So I think those were kind of our ideas for where we wanted to go next. But I think it's a really, really smart question about, how do you think about the label? And how do you choose what am I actually predicting, and is what I'm actually predicting a good proxy for what I actually care about, which I think is a really, really hard problem.
Y yo creo que vamos con la última. Si quieren más preguntas, ahorita vamos a hacer un pequeño networking, entonces que no se van a quedar sin preguntas.
Okay. This is another question. This is not a follow-up to I'm going to answer in Spanish. So, tu pregunta de cómo responder cuando había esto, Kit no estuvo en esto, decir, pero creo que hay, yo he estado en dos casos, estando en Chicago, pues hubo una presión para hacer este tipo de cosas, y ha habido otros casos igual estando en Carnegie Mellon donde ha habido presión como para utilizar el modelo para cosas que no son las que estaban originalmente puestas, ¿no? I'm going to talk about the SFPD.
Yeah. Oh, yeah. That's actually a good example.
We have one in UK, in which they wanted to use the model for doing some expulsion of the immigrants, illegal immigrants.
I don't think I knew about that.
So, creo que hay primero, una vez nos mencionó Kit, este proceso de validación que Kit mencionó es súper fuerte. O sea, dedicamos muchísimo tiempo a seleccionar eso, qué proyectos son para que el partner sea lo suficientemente alineado con nuestros intereses y que que van a utilizar esto para hacer cosas buenas, pero aún así pueden existir. Entonces, hacemos ese proceso de validación y dos, a la hora que hacemos los acuerdos legales, siempre nos quedamos con la posibilidad de que no importa lo que encontremos, esto lo podemos publicar. Esto es lo primero que, entonces es un acuerdo legal, que nosotros podemos publicar lo que encontremos. Entonces, regularmente hay gente que no quiere hacer esto, y nosotros no lo hacemos, pero esto nos protege. Entonces, el ejemplo que estaba yo diciendo era un proyecto en el cual en Inglaterra íbamos a seleccionar qué personas iban a estar en condición de ser rough sleepers, que no es como, sí, horrible. Entonces son personas en situación de calle o son personas que acaban de quedar en situación de calle. Y el gobierno de Inglaterra quería acercar recursos para llevarlos a shelters. Y luego una agencia aliada quiso utilizar eso para identificar inmigrantes ilegales y deportarlos. Y obviamente nosotros actuamos, nos paramos legalmente para que no pudieran hacerlo, aplicábamos cosas por el estilo. Entonces es un primer apoyo. Pero en el caso de la policía, no lo puedo decir. Policía, hicimos un modelo que ya hemos probado varias veces y el departamento de policía en particular no le gustaban los resultados y quería que los modificara. Que el reporte quedara, que les diera mejor luz a lo que ellos hacían. Y ahí creo que lo que es muy importante es lo que yo he aprendido trabajando con Kit y con Rayid, es que hubo integridad. Básicamente, Rayid Gandhi, que was our former boss, estuvo aquí. Sí, no. Rayid va a venir, pero él estuvo en un dato antes. Tiene sus valores para hacer este tipo de proyectos, tiene una gran integridad y él estuvo firme que no iba a cambiar ninguna de estas cosas. Entonces, creo que una cosa es el apoyo legal que uno hace antes de esto y la otra es que el equipo que forma, que trabaja en esos proyectos, pues sea elegido por su integridad también, y que se mantenga y que haya apoyo institucional, que haya apoyo de la jerarquía del grupo para poder hacer las cosas. ¿No? Eso es básicamente. Si cualquiera de esas dos cosas falla, está uno perdido. Y Kit en algún momento mencionó que uno tiene que optimizar por su tiempo. También la selección de proyectos es, si el proyecto no es valioso, si no va a servir de nada, si lo quiere nomás para cubrirse de gloria o lo que sea, pues uno tiene la capacidad de decidir, no lo voy a hacer, ¿no? Y luego la otra, para la persona que preguntó dónde podía colaborar. Además, obviamente son institutos muy grandes, muchos proyectos profesionales en escuelas de renombre. Nosotros somos, no un spin-off, pero somos parte del grupo. Entonces también es una forma de intentar aquí colaborar y hacer cosas. Y pues todos nosotros colaboramos y trabajamos juntos. Entonces sería una buena opción. Sí, lo tienen que considerar.
Incluso aquí han presentado algunos proyectos con organizaciones en México y datos en México que no siempre han terminado con un proyecto de decisión, pero que pueden ver incluso en el canal de YouTube. Ahí hay varios. Hay uno de crimen organizado que se va. Amplia, que se va. Muy bien. Bueno, pues eso es todo. Por favor, démosle un aplauso aquí. Y vamos a hacer